now we'll pick up where we left off in the previous tutorial. We had drawn this linkage, right? We'd drawn it 180 degrees. We divided the window up into a quadrant system, and we tested this at various angles. What we'd like to do now is we'd like to have this start rotating about the origin, right? We want to then start simulating the forward kinematics of this single linkage. All right. So here, let's just go ahead and let's put theta 1 back to 0. Let's now, in order for this to rotate, we need to increase theta 1. We need to change theta 1, right, each time through. So let's make a delta theta 1 variable. Its units will be degrees as well. Right, to give this angular velocity, then we'll just update the angle. So let's write a function void update theta 1. And we can do that as simply as theta 1 equals theta 1 plus delta theta 1, right, as a start. And then we need to call our function update theta 1. So let's do that in here. Update coordinates is dependent on theta 1. So we want to call the function update theta 1, right, before we call the update coordinates. All right, and let's comment out no loop then. So this will go through. Let's run this. And oh, I forgot to initialize delta theta 1. Silly me, right? We created it, but I didn't give it an initial value. Processing initializes everything then, right, to 0. So delta theta 1, let's make that 1 degree. Now we should see some movement. Good. All right, we've seen some movement then here, and we're seeing it's going to keep rotating all the way around. All right. All right, now we want to constrain this to within, right, this region of 0 to 180 degrees. So let's add some code in here. So I'll stop this running. Here, let's just go ahead and say, well, actually, let me show you one other thing. If I change this to -1 delta theta, so all I've done was change the direction of our angular velocity. Notice we rotate in the other direction. So when we want to reverse directions, we need to negate delta theta 1. Right? What we're going to do here is, let's just say if theta 1 is greater than or equal to 180, well, let's just call no loop, so that we can read those values and see that finished value. All right. So we're going to rotate from 0 to 180. We get there, and then we stop. And we can see theta 1's 180. Now, this is a little bit difficult to read. Notice we're getting different amounts of numbers to the right of the decimal point. All right, let's clean up our output a little bit. All right. So down here, where we're displaying the coordinates, okay, AX and AY, well, those are fixed with 1 decimal point. Those aren't going to change. BX and BY, well, we can round things. So theta, right, theta we're staying with whole degrees. The reason we're staying with whole degrees is that eventually then these units, these theta 1, the value of theta 1 will be transmitted over to Arduino to control the servo motor, which requires us to send it values, integer values that represent whole degrees between 0 and 180. Right. Now, there's a function then in processing where you can control what you see. We can ensure this is always 1 decimal point if we just say NF for format. Here's a number we want to format. If I want 3 places to the left of the decimal point, and let's keep our 1 to the right. All right, we'll get that, and we're already getting that. Let's do the same thing here. Let's just say NF, so BX, all right, and I want 3 to the left, to the right. Actually, let's make this 4 in case we change our window size. Might have to update that. NF BY, format that with 4, 2 decimal points to the right. And all right, so we have a format that's a little nicer, except now when we do the 4 to the right, notice here we're getting the 0 in front of that, and 0 fills. It's not my favorite thing in the world. Let's just go to the 3 now, because we know based on our window size, that'll work. We're using this more or less for debugging. All right, just for our own information here. All right, so now we've got everything formatted a little more neatly. So the other thing then we want to do, we can constrain this. Right? Instead of no, oh, we saw our other method then was, let's go ahead and make this, so let's initialize theta 1 to 90. Right? And let's make delta theta 1 minus 1. Right? And let's write some code that says if theta 1 right, is less than or equal to 0, we want to constrain it there. Right, let's call no loop. All right, so we constrain that here at 0. If we wanted this to come back the other direction, instead of calling no loop, right, I could simply say that delta theta 1 is equal to the opposite of delta theta 1. Right? We're going to reverse direction of velocity, angular rotation. Right? We go back over here, and then we hit that no loop condition. Well, then we could do the same thing here. Instead of no loop, we could constrain this. All right. Now notice we have 2 separate tests that when they're true, we perform the same action. So we can write this, I could write this as an OR statement. Or I could have made that an else if. But let's do this. Get rid of this. Make it a little more efficient. All right, and that seems to be working. Good. All right, now that's working really well with delta theta equal to 1 degree. It's a nice even multiple, right, of 0 and 180. But what happens if now, let's make delta theta 17. And let's start back at 0. Well, now we've got something bouncing back and forth so fast we can't really see it. Let's go back to this idea then of calling no loop when we reach that condition. All right, so we can see what that stopping point is. All right, so over here as we went from 0 to 180, when we performed then this addition, so we were at 170, we added, so theta 1, we added 17 to it. Theta 1 then became 187, which is beyond our 180 boundary. Right, we want to make sure we don't go beyond that boundary. We need to write this constraint just a little bit better. So in this case, right, we didn't really want to add in this delta theta that made it beyond that. Right. But we had to add it in to see that it was going to go beyond. Right. What we might want to do is we want to back that out and say, well, then after we reverse delta theta, let's just set theta 1 back basically to where it was. So if I say theta 1 plus delta theta 1. And, oh, forgot my 1 here. All right, so now we get 170 twice. Well, we get that 170 a second time simply because no loop allows us to go through the loop one more time. All right, but that's good. We didn't go beyond our 187. All right, sorry, beyond our 180 to get the 187. Now, will the same thing still work for 0? So if we start this, then delta theta at minus 17, and instead of starting theta, let's start theta back here at 90. Good, we constrain this to be above 0. And will this work for some other values? Will this work for, oh, let's say minus 9? That seems to work as well too. All right. So we don't want it to go beyond the boundary simply because the hardware that we're going to control with these numbers needs to be in the range of 0 to 180. So that's one way then of constraining that value. There are other ways you can write this to constrain this, right? But now if we take out the no loop here, right? So constrain theta 1 to the range of 0 to 180 inclusive. Right. And now that delta theta is huge, so let's put it back to some other value. Let's put this back. Maybe 2, start at 0, and let's see if we can watch it go a little more slowly. Right, back and forth. All right, so now then you've got this motion of the single linkage that's rotating between 0 and 180. Right, your next step after this would be to write the sketch in a way that you can start transmitting this to the Arduino where you have that single linkage attached to your servo motor and control that. Right, so